Namaskaram. Good afternoon. Welcome to Mana TV live classes on physical science pedagogy. We discussed various concepts in the pedagogy, the method of teaching of physical science, the different resources, various books, different strategies, the textbook philosophy, and the curriculum of physical science. So today we are going to discuss about the most important, of course, is a part and parcel of physical science teaching, how physical science is concerned with daily life situation. This is the most important. We can't differentiate the daily life situations and the physical science. The reason is, in general, physical science have units and dimensions, kinematics, dynamics, simple harmonic motion, optics, electricity, magnetism, sound, modern physics, nuclear physics, solid state physics. These are the various parts of physical science curriculum. So if you take any one of the chapter or any one of the branch of physical science, every chapter is concerned with the daily life situation only. It develops the scientific attitude, logical reasoning, and intrinsic heart among the children. So as a teacher, we have to know how each chapter is connected with the daily life situation. This is the most important. As earlier we said, every chapter started with the notion of the chapter. What is notion here? The notion means how the chapter is going to be introduced and how it is concerned or correlated with the daily life situations, and what are the prerequisites to transact the class effectively in the classroom situations. So here notion is concerned with the daily life situations. So you have to learn all these things for good transactions. Okay, already I suggested various books, websites, magazines, and organizations which provides excellent environment to learn all these concepts. Now coming to the units and dimensions chapter. So units and dimension chapter, generally you have screw gauge, vernier calipers, okay, spirometer, and other units. Okay, so in all the units generally we are using. If you want to purchase some vegetables, you will be purchased in terms of kilograms. Kilogram is one of the unit for mass. If you want to measure some length, maybe meters, maybe kilometers, maybe centimeters, maybe millimeters, all generally we are using in the various conditions, correct? And if you want to know the for example time, so your class will start at 4 o'clock, from 4 to 5 it's a live class, so you are saying 4 p.m. to 5 p.m. so it's time. So for every day we have 24 hours, there is an advertisement 24/7 works, means each and every activity is concerned with these basic physical quantities, of course, mass, time, and length, correct? So we can't see without a daily life situation. There is no mechanical, there is no possibility by heart it, and there is no possibility for a rote memory. Am I correct? So, and we have various kinds of systems also. Previously we have a FPS system, and next one is concerned as a CGS system. Next it is modified as a MK system. Presently it is SI system, system of international units. Okay, so three more added. Totally now there are 7 basic quantities. So like when you take anything, so even force, for example, you are measuring the force in newtons, energy in terms of joules. So like each and every, if you want to know about calories, that's also how much energy it is utilized in the form of calories. When you do yoga or when you do exercises, okay, when you eat some parota, how much calories you will get. So for example, you are using body mass index, BMI, okay, for certain height you have to maintain certain weight, otherwise your body will be fatty and you have to face so many problems. If otherwise if it is very less, body mass index is very less, then you have to improve your body strength, otherwise you will get some diseases. Like everywhere you are using these units and dimensions, so that's an application of units and dimensions. We can say so many. And now coming to the shift to the another one is kinematics. We have pure kinematics and applied kinematics, of course. In kinematics is concerned with the motion of a body. So here when you consider only the motion of the body and not concerned with the applied forces, whether external force or internal force, that kind of study is called kinematics. So if you want to know about whether the body is at rest or in motion, so already you know that moment of inertia, or simply call it as inertia. A body which is at rest or body which is at uniform motion without applying a external force, the body maintain the same status, means it is at rest when it is rest. It is at uniform motion, it will be uniform motion. That is called inertia. Already we gave so many examples. For example, if you want to remove the dust by pushing your blanket, then you have just you are moving the blanket, then the dust particles will fall down because of inertia. When you travel in a bus, so when bus driver applied the bus brakes, so you will pull forward. The reason is your legs will come rest and the rest of the body is in motion, hence you are just pull forward. So like you can say infinite number of examples. Here we are using reference frames. That is very, very important. Reference frame means here when you travel in a car, when you observe the surroundings through the window, the surroundings seems to be which are rest are in motion. Actually you are in motion because you are traveling along with the car. So you are in motion, but you feel that you are at rest and the rest of the things which are in rest, they will be seems to be motion, means it is called a relativity. So we can say about relativity. Their reference frame, with respect to reference frames we are saying, and very important thing is Newton's laws. So you know that then first Newton's law is the inertia, law of inertia, already just now I discussed, and second Newton's law you know that is rate of change of momentum. Rate of change of momentum is called force. Okay. So means here when you feel that there is some force is applied, there is a change in the position of the body. Am I correct? So rate of change of momentum. Momentum means here mass into velocity. So when you possess some force on that, then the velocity will be changed. So the rate of change of velocity, of course, into mass, that is called momentum. The rate of change of momentum is called force. So like now coming to the third one, it is you know that for every action there will be equal and opposite reaction. That is called Newton's third law. Even rockets are working on Newton's third law. Even for example, you want to travel in a horse cart. Okay, now horse carts are not available in the present Hyderabad city or any other, very rare. At most probably I think so in Mumbai and Calcutta there is a possibility of these horse carts. Okay, so how the horse cart will travel? Can you understand those things? Just it push that land with its legs. So that's an action. There will be equal and opposite reaction, means here the bullock cart will be pushed or pulled towards the forward direction. So it moves like. So here there is an action, there will be opposite equal reaction. If you want to swim, so what you have to do? Just you push your water backward direction. How much force you apply to push the water in the same force in the opposite direction, so the water will push you or means simply pull you to forward direction. So that's in this manner you are swimming on the water. So that's it's nothing but Newton's third law. Like we can give infinite number of examples how Newton's third law is applicable. Clear? So all this comes under the chapter of kinematics. So it's the most important. And when you come into the applied kinematics, means here when a body in rotated motion, circular motion, when it is in a circular motion, what will happen? So what will happen? So here there is no possibility. So in circular motion, it's instead of linear velocity, it has angular velocity and angular acceleration. You know that when the body is moving, so at the top position, it is the velocity will be square root of 5 r, and coming to the bottom it is r. So like we can say, and very, very important is the angle of banking. Okay, the angle of banking means when it travels in a curved path. So there is an angle of banking. The formula you know that, it's a very important, that is tan theta equal to v square by rg. This is a form. This theta is called angle of banking. Tan theta is equal to v square by rc. Very clear? From this you can understand so many concepts. When you travel in a curved path, the velocity should be less, the radius of curvature will be more, and the acceleration due to gravity is same. Are you understand this? So it's these are the precautionaries for when you traveling in a curved path. So for example, you travel in a Tirupati Ghat roads, you have to take some care. So you have to take more radius of curvature and the velocity should be less. So how you are going to say this? Because tan theta, so tan 0 is 0, tan 30 is 1 by root 3, tan 45 is 1, tan 60 is root 3, and tan 90 is undefined. Tan 0 is 0, tan 30 is 1 by root 3, means here less than 1. Tan 45 is 1. Tan 30 is root 3 is 1.732, means as the theta value increases, the value also increases. So means here you want to minimize, of course, minimize the theta, angle of banking, then the velocity will be less and the radius of curvature will be more, because when the denominator is more, then the total fractional value will be less. So you want to minimize that. When you minimize that, angle of banking also minimize it. See how interesting this. So this is a scientific attitude. So in this manner, so these railway tracks and other things will be constructed. Even this is called angle of banking. Is it interesting or not? So like so many concepts in the kinematics chapter. Okay, now coming to the next one is friction. So when you come to the friction, I am standing on this dais because of frictional force between my leg and the, of course, platform. If there is no frictional force, I may fall down. Am I correct or not? So it's a frictional force. So that's a very, very important. Due to friction, so there is a possibility of fire and all the things. Okay, so that's friction has so many things here. So and between to reduce the frictions, we are using the small balls in the generally on the vehicle wheels. Am I correct? So generally we are using that. Like so many applications in the frictional. Now come to the next one is dynamics or dynamics. So dynamics means here we will observe the applied forces, means external forces also. And external force means here, for example, you will consider the air resistances also. This is the most important. Here the external force is the frictional force or applied force on it. External force, that is. So how when external force applies, what is the change of momentum or what is its position? This is a very, very important. This physical science concept is concerned with the chemistry concept also, that is called uncertainty. Okay, Schrödinger uncertainty. Okay, uncertainty means for example, if you take you want to know the position of an electron in an atom. So if you want to know the position of an electron, you have to provide some kinetic energy to the atom. So means your electron will get the kinetic energy or external energy, which is provided in the form of electromagnetic wave or something else. It's the kinetic energy changes. When kinetic energy changes, then what will happen? So its momentum will change. When momentum will change, so the velocity of that will be changed. When the velocity will be changed, the position of the is changed. You know that there is a formula. You know that Ke equal to P square by 2m. So kinetic energy is nothing but, of course, P is the momentum and m is the mass. It is the relation between the energy and momentum. Clear? So like by using this, you can say about uncertainty principle of electron. Okay. So most important. Now coming to the next one is the sound. You know that how the sound will comes by vibrating of the particles, objects. When you make any object which is in the form of a vibration state, then the sound will be developed or released or produced. Am I correct? And just we have a vocal cord here, and when in this vocal cord the vibrations takes place, according to the vibrations we are able to talk. So like but it is a very important and very interesting thing also. It is not possible to listen every sound, because if the frequency of any sound will be lies between 20 hertz to 20,000 hertz, then only we can hear that sound, otherwise it is not possible. Okay, so if it is less than 20 hertz, it is not possible to hear, and if it is more than 20,000 hertz, it is not possible to hear. You know, or you know that the frequency produced by the bats is 1 lakh hertz. So that doesn't it's not possible to hear by us. So in the nights of in daytime, they are of course the bats unable to see. They produce these sounds. Okay, this is called supersonics. So they produce the sounds. So according to the sound wave which is produced by bats, in that direction the bats will travel. For that reason, most of the bats are died at current wires. Maybe you observe in that. What is the reason? The current wires, electricity wires, of course, they are in parallel. When these sound waves are produced in a straight line path, if the two rays are of course travel to between the two current wires, then what bat will feel? There is no hurdle. So it flies in that direction only. So both the wings will touch the wires, and most of the bats are died. Correct? So this is science simply. And even dogs, nearly 50,000 hertz, they produce the 50,000 hertz sounds. Okay, so and it's that sounds is some sounds will not be audible for us. So they touch the ground and they make some sounds. So we feel that the dogs are hungry. That's the reason they are producing the sounds. It's not correct. Actually, if they can hear up to 50,000 hertz. So that's the reason if there's some earthquake will comes, that is called primary waves. When the primary waves comes, then its frequency is around 45 to 50,000 hertz. So that sounds will be heard by only dogs. So our ear cannot be in position to hear. That's the reason we are unable to identify, but these dogs will identify those things, and they will give some sounds. Means we feel that these dogs are making hungry. That's the reason they are just one kind of what you call it, sounds they are producing, because the dogs can hear up to 50,000 hertz. See how interesting each and you come into the other one, the sounds we call it as a Doppler effect. And so Doppler effect means here when the train comes, of course, nearer to us, we can hear the more than actual frequency produced by the train. When it left from us and moving away from us, so we can hear the sound which is less than the actual frequency which is produced by the train. So there is oscillation of sounds. This is which is called Doppler effect. Okay, now we can identify. So see, we can identify those things also. Some when you are playing, just as in at our child age, most of the children they will put their ear on the railway track. Whether the train comes or not, they are going to identify. Am I correct or not? So these sound waves can travel through this of course media which is in the form of rails. Correct? The sound can travel any media, any elastic media, but sound cannot travel in vacuum. One of the important application of this vacuum is due to nuclear fission, sun releases the energy. Okay, when the energy comes, all of you know that. That's a very, very, very important. I will write that equation also. See how it is. That is inside that is called photosphere of sun. 1H1, there will be hydrogen. 1H1 plus 1H1 gives rise to 1H2, and 1H2 plus 1H1 gives rise to 2He3, and 2He3 plus 1H1 gives to 2He4. Okay, 2He4 plus 1. One positive will comes. So in this process, this is called nuclear fission. In the nuclear fission, so a lot of energy will release. When a lot of energy release in the form of heat and light, that's the reason we are getting heat and light from the sun. In between, when the energy is released, big sounds will come. Okay, so if the sounds that comes directly to our ears, then in the universe, no animal, no living human being or no living animal cannot hear, because our ears will not work. But the main reason is between our environment and space, there is some vacuum. So sound cannot travel through vacuum. That's the reason. So we are unable to hear that sounds. Just we are getting but light can travel in vacuum also. So we are getting light, we are getting of course heat energy, but we are not getting sound energy which was produced by the sun. And in a sense, how interesting this. So it all concepts will comes under the sound. And very important thing is, so our ear cannot distinguish the sounds if when the two sounds comes less than 1/10 seconds. Okay, if it less than 1/10 seconds, you are unable to. That's a difference between classical music and rock music. In the rock music, they are using so many counts. They are producing so many. So you are some drumming will be there, but you are unable to identify which kind of sound will be produced by which instrument. But when in a classical music, you can identify easily. It's come from veena, it's come from guitar, it's come from tabla, and it is come from mridangam. So like you can identify clearly. The reason is between the sounds produced by those instruments reaches our ear more than 1/10 seconds. So that's the difference between the classical music and the rock music. So like we can apply this sound knowledge in the various instruments, and of course how it works. Everything is in a scientific manner, scientific mode. So that comes under the sound. So it's a good application. Am I correct or not? So you can so we make, of course, when you take bamboo and when you make some holes. So when you leave the air, so we will get beautiful sounds, of course, and of course is simply because Pillana Guruvi. That's it's a greatest instrument in the hands of Sri Krishna, Lord Sri Krishna. So like we can say excellent examples how the sound is concerned with our daily life situation. Clear? Okay. Now coming to the end, if you hear the maximum sounds, and then that will causes some brain problems also, medical problems also, and we have sound pollution. Just you know that. So every people, especially in corporate, of course, in metropolitan cities, and these people. So even though they are living in a metropolitan city, most of the people are uncivilization and they don't have any civic sense. Simply whether it is sound is necessary or not, they will blow the horn. So which causes the sound pollution. So it causes so many psychological diseases to the people. So as a educated and as a civilized people, where the sound is necessary, there only we have to blow the horn. We should not blow the horn everywhere. And it is not a testing time. So whether the horn is working for our vehicle or not, it's not the testing time. So we should not teach the people also. It's a civic sense for that. Clear? Okay. Now coming to because why I said these things here. So science should learn social values, ethical values, and moral values also. Not only scientific values, but also we have to explain those things which is necessary for, and we call it as it's a life skills. These are most important. Okay, now coming to the next one is light. So light, when you consider the light, so you know that without light we can't live. Am I correct or not? So if there is no light, if a blind people doesn't see anything. Of course, his mind is what at least works. When the total is, if there is no light, it's a very difficult. So we are getting light from this one of the star like sun. Am I correct? And light has an excellent properties. So and now every people due to different indeficiency of deficiency, especially deficiency in the food and nutrition. So we are getting after 40 years age generally we are getting eyesight problems. Am I correct or not? So generally we are using specs and spectacles and we are using various kinds of lenses. So lens comes under the optics. Am I correct? So what is a lens power? So when's the lens power? According to that we are going to calculate it. Then only maybe some people are short sight and some people have a long sight. According to their sight problems, we are using the various specs with the different kinds of power. And this comes under the optics. Am I correct or not? And most important is light has so many properties. You know that one is called reflection. You are seeing your face. Is it possible to see your face? Yes, you can see your face through the mirror. Correct? So what is the concept and what is the properties there? It is the reflection of light. That's the property of reflection of light. Some light rays incident on us, they reflected, they incident on the mirror, again they reflected, and our eyebrows will identify. Of course, brain will identify this. Retina will identify that. Finally, you are able to identify that that's your face. So you are able to see your face through the mirror because of reflection of light. Okay. And you know that another property is refraction of light, that is when you put a spoon in a water glass of water, it seems to be like it's bending. Okay. The reason is when the light ray is travels from the rarer media to a denser media, the light ray bends, and when the light ray bends, the image seems to be like bending, but actually the object will not bend. Am I correct? And when the rain comes, okay, when the light is there and the rain comes, when the water drops are formed on the leaves of the trees, when the light ray incident on it, that light will be scattered in the form of a rainbow. So VIBGR, violet, indigo blue, green, yellow, orange and red. Clear? It's a VIBGR. How the rainbow will form because of a scattering of a light. Okay, like you can say, so when you see at the morning sessions on the roads, so there is some dusty water is there, okay, and there is a mixing of so many oils, maybe grease, maybe petrol, maybe diesel, or maybe other things. So when you see that, there are, you can see different kinds of colors will be there, because the light ray travels in the various kinds of the mediums. Obviously the color exhibited by them is a different one. So like everywhere you have the signs. Am I correct? So this is the most important. Now coming to the next one is lasers. So lasers, you know that by using laser technology we can use, so we can represent so many pictures, and we can use for lasers for cutting of hard materials and laser photos. Okay, laser treatment, you know that in medical you have a laser treatment is there. So like very good application in of course lasers. Clear? And we have different kinds of electromagnetic spectrums. You know, you have X-rays, we have cosmic rays, we have visible rays, correct? So like you have so many things. X-rays are used to, you know that by using X-ray you can, where our body parts, of course, where the bones were broken, and is there any disorderness in our bone system. So if you want to know, generally we are using the X-rays. So there we are using the light. Am I correct? So these are the things which are highly applicable for light concept. We can say even 3 or 4 days without giving any kind of interruption about light. Such a great thing about light. So due to time constraints, we are going to shift for the next one, that's as a magnetism. So you know that the magnets are highly useful. We are using the magnets, horseshoe magnets, pot shaped magnets, round shaped magnets, bar magnets, correct? These are the various kinds of the magnets. Generally we have bar magnets, of course. Sometimes you are using electromagnets also. For example, some goods are bring by one ship, okay, so that it's a very big ship. So you want to move that content, of course, material from ship to port. Is it possible to hold all those things here? Then generally you are using electromagnetism. So electromagnetism means when you apply current through it, then it acts as a magnet and it attracts that container, and it brings back on the port, and then they will stop the electricity. Then it becomes again a simple iron piece. So it's called it as electromagnetism. It has very good properties, correct? And magnets, you know that magnet means we can use it to various purposes. A magnetic needle is there. So these aeroplanes, so if you want, so there is no signal lights on air. Am I correct? So there is no signal lights. If you want to travel, so on road there is some signal lights, but when you want to travel on air or on water, so these magnetic needles are highly useful to know the directions. Am I correct? So north and south, north, south, east, west directions, if you want to know that, this magnetic needle highly useful. So if you want to travel it, definitely you have some knowledge about this, the working principles of magnetic needles. Am I correct? So like we have excellent opportunities or applications of this magnetism in our daily life. Now coming to the electricity, this is the most important. So electricity, now without electricity, imagination of our life is totally miserable. Am I correct? Okay, so every time, so here Using even transmission of this live class also electricity is required. Okay. The fans are working, not only fans, refrigerators, air conditions, electrical cookers, okay, washing machines, water purifiers, like every equipment generally it's working under by the help of electricity. So electricity is most important. Without electricity we can't do any daily life situation. Means I am saying presently we are habituated, we can live without electricity, because before invention of electricity the people are living there, but so now we are habituated for the electricity usage. So definitely electricity has a very good application. Okay, we have a static electricity and current electricity. Static electricity means here you can, so when you rub your hair with a comb, after few seconds when you see that, so when you take a piece of paper it attracts. So that is called a static electricity, and there you are going to learn about various concepts like potential, capacitors, resistance, all these things. And now coming to the current electricity, the flow of free electrons is called electricity, and there you are going to learn about voltage, okay, and other potential difference, electromotive force, EMF, electrical cells, batteries. Of course, combination of electrical cells are batteries. Generally we are using a small thing, one is called wrong usage. The electrical cells which are available in the market we are called as a battery, but battery means a combination of electrical cells. Generally it is the battery which is used as a battery, that is as a 1.5 EMF. Okay, so we have to know the difference between the voltage and EMF, electromotive force. That's a good application, correct? And how the dynamo works, how the projector works. So if you want to know all these things, different kinds of Ampere's law, Fleming right hand rule, Ampere's right hand rule, like you have to know the various kinds of rules, and these are highly applicable to know the how the current flows. And very important things are Ohm's law, you know that, Kirchhoff laws, these are also very useful. The Kirchhoff laws are used in loops, am I correct? So like very good application and the concept. So here we can enjoy by teaching of mathematics, of course physics. So maybe sometimes you feel teaching of mathematics is a boredom, but physical science is enjoyable. We can deliberate our class transaction in an effective manner by giving n number of examples about each concept, and the children also living with physical science concepts, so definitely he can understand easily, but no children will feel physical science is a difficult one. But unfortunately physical science children, of course teachers also feels a little bit of uncomfortable. At the same time children also feeling difficult to learn the physics concept, means we are not integrating the physical science teaching with the daily life situations. We have to explain that. That's the most important. And there's some numerical problems. When you consider the numerical problems, so this is very important. When you explain some numerical problems, then only the children can learn it easily. Why? What is the necessity for explanation of the numerical problems means, for example, how much electricity is consumed per month, because that electricity people will come and they will give an electricity bill to you. So this month you have 678 rupees for you consume that for that. So how is calculated, and you have to calculate that, how you calculate the units, how you calculate the reading of the electricity. This is very important. So for example, there are 4 tubelets, you know that there are 4 tubelets. Each one 40 watts and used for 6 hours per day, and there are 60 watt bulbs, we have 2, and you have used it for 4 hours per day, and you have for example fan 100 watts and used for 6 hours, and you have 2 fans, these only. You want to know how much electricity is consumed per month. 4 fours of course 160 and 960 is 960 plus 2 fours are 8, of course 8 6 is 480. and 6 to the 12, so 1200, correct. So 960 plus this is 1440 and this is 1200, okay, means here simply 1440 plus 1200 is okay, 2640, okay, and it is for 30 days, okay, you multiply with 30 days, so you will get 0, 4 3 is 12, of course, 3 6 8, 18, 19, 3 2 is 6 7, okay, you have to divide with 1000, means so 79.2 units, simply you can say 79.2 units. So you consume 79.2 units per month. So according to the rate, they generally they will explain, of course they will give the bill for you. So this is very important, correct or not? Sometimes you feel that I am getting much more amount for this, I have to pay, so there may be some meter problem, like you feel that, then you have to calculate that how much electricity is consumed, then you can apply your objections to the department. Am I correct or not? So see, this electricity is concerned with our daily life situation. Okay, now coming to the next one is modern physics. And the modern physics are concerned with the atomic structure and other properties also. You know that you have okay, substance have molecules, molecules have atoms. Atom consists of electron, proton, neutron, and proton, neutrons are at the nucleus and electron revolving around the nucleus in elliptical orbits. Okay, up to this, so it's okay. When you come into the modern physics, so it's a little bit of advanced, that means here inside the nucleus not only proton, neutrons, so many other things are there. There are positrons, okay, mesons, and okay, like neutrinos. These are the various kinds of the things. How these particles are the things that happens. So for example, I will give a small example to you. So a proton will be converted into neutron, and neutron will be converted into proton. So for example, what is proton? You can say 1p1, it's a proton. The proton will be converted as a neutron, means here, and it is 1 n0 plus minus 1 e0. Okay, the proton is converted into neutron, and other one is it is called electron. I have a small doubt of this. So generally, just now I said the word electrons are around moving around the nucleus in elliptical orbits. So it's an outside, it's an exterior to the nucleus. But I said when proton is transformed into neutron, electron will come. So there is no existence of the electron inside the nucleus. So simply it comes out from that. So the electron which is ejected from the nucleus is called simply we call it as an electron beta ray. That's a very important. Okay, beta ray. And when you come into the neutron 0 and 1, it is converted as a proton 1p1. Okay, so this is a 1p1, and of course here you can say this is okay, this is minus 1 e0. This is 1 minus 1, this is plus 1, okay, this is a 1, it's no electron, this is 1, and this is a minus 1, this is called a positron. This is the most important, okay. So that comes under the positron. So positron, you know that anti-proton, anti-neutrons also there, but in anti-substance, not in that, a little bit of advanced stage. But here from this you can understand alpha rays, beta rays and gamma rays, which leads to nuclear physics. Okay, this is the most important. So nuclear physics, so it gives very important concepts. So some objects where are some substances, simply some substances where the neutron proton ratio n by p ratio is more than 1. When it is a more than 1, then they are acting as a radioactive element. Okay, so radioactive element, that's very, very important, radioactive element. So you know that cesium-137 and other, if any people are suffering with a cancer, the first therapy is given to those cancer cure is a radiotherapy. So this is the most important. Okay, and if you want to know the age of ancient things, so we'll use the carbon-60. Okay, and if you want to reduce the one of the disease called goiter, so there is a radiosodium. Okay, like so many radioactive elements are useful for the medical sciences. Not only medical sciences, a very big crack comes under the one of the blast furniture. Generally we are using radioactive element where the crack appears, and by applying for that you can identify, you can remove that particular area part for the blast furniture. So like not only these examples, we can say infinite number of examples for this nuclear physics. So the nuclear physics as generally explains about nuclear fusion and nuclear fission. This is the most important. And the nuclear fusion and nuclear fission means nuclear fission. So when a neutron is bombarding with the one of the medium substances, then that's of course that radioactive element will be divided into two substances, and 3 neutrons will be released. These 3 neutrons again will bombarding with other atoms, and which causes as a nuclear fission. This will take in fraction of seconds, the process. This is called chain reaction. I understand the chain reaction. So if there is a chain reaction is controlled chain reaction, then we can use it for different constructive purposes, like nuclear reactor, which converts into this nuclear energy into electrical energy. Maybe recently in Andhra Pradesh also at near Narsannapeta, I think so, it's a Kovada village. So government want to start a nuclear plant for producing the electricity, okay, by using nuclear reactors. But every people is let's say because some radio waves will be released, it's very dangerous. And recently 1 year back, I think so, in Japan, so those nuclear reactors are due to earthquakes, they are blasted, and it's very difficult to survive in the particular area. So the world is again seeing whether we are going to construct nuclear reactors or not. But if it is uncontrolled, then the nuclear reactor will be converted as an atom bomb. This is a very, very important. So we have to see that, because science is a double-edged knife. Science is a double-edged knife. Don't feel that. So if anything happens, so if it is uncontrolled, we can use a double-edged knife. Means a knife can be used to cut to apple and to do various, of course, various pieces, and we can give it to all the people to get enjoyment of sharing the food. At the same time, you can use it for the other purpose as an antisocial element. So it depends on, maybe you know that Universal Becquerel actually invented this Atahan, I think so. This invented atom bomb for the welfare, of course, of the universe. So especially in deserts, there is no water. So but there is a research that when you go in depths of the deserts, so there will be some water resources. When you blast this those things by using atom bomb, the ground level water will comes upwards and give some water resources to the people. So they are accepted. But unfortunately, these atom bombs are used for because for the political dominance. You know that in 1947, in the Second World War, this American dropped atom bomb on Hiroshima and Nagasaki, and totally it disturbed the financial and system of Japan, which correct. So usage of science should be in a proper way. That's a very, very important. This is about nuclear physics, and you can say we have very good applications also. And how you can, if you want to understand how the energy will be released from the sun, just now I discussed because of nuclear fusion. So nuclear fission and nuclear fusion are the different various concepts, and there are so many radioactive series also. We have 4n series, 4n plus 2 series, 4n plus 3 series, and 4n plus 1 series also there. Out of these 3 are natural radioactive series, and one is artificial radioactive series. So natural radioactive series ends with lead, and radioactive series, of course, artificial radioactive series ends with bismuth. So this is the difference between these two. So nuclear science is very useful, and now we are coming to the physics converted into nanophysics. So you know that the nanophysics is highly applicable. Now recently they want to do these operations by nanomedicine. Now recently we are going to apply for the nanomedicine. They will send that medicine through the blood where the problem is there. So without any kind of surgery, they are going to use this nanomedicine for curing those diseases. So we are reaching the peaks of the knowledge height, so because of physical science. Am I correct? Now coming to the next one is this space physics. So you know that space physics, we started with a small step, but we are making a marathon, and especially in projecting these satellites in the universe. Recently, already number of times we memorized and we explained those. Our ISRO doing an excellent job, and they are 1 month back they projected nearly 104 satellites in the universe, of course, in the specific orbits, and they are functioning excellent mode. So it's a great achievement by our Indian scientists. And one week back, 34 satellites also launched in the specific orbit. So it's a great achievement, and it means our of course scientists are doing their job in an excellent mode. So because of they feel that science is a part and parcel of daily life situation. It's not a new thing. There is no abstractism. So there is everything is in a concrete examples. We can give excellent concrete examples for application of science in a daily life situations. Okay. Now coming to the next one, we have a solid state physics. Solid state physics means there is a different why some of the substances have a crystal structure and some of them is a different structure. You have to know all of these things, means you have to know about the solid state physics and crystal form and various kinds of boiling point, melting point. Okay, these are the things comes under the chapter of thermodynamics. This is the most important, and by using this thermodynamics, then we are preparing hard packs. Hard packs is working on a concept of thermodynamics. Am I correct or not? And even we are using thermometers, clinical thermometers. By using clinical thermometers, whether you are suffering with a fever or not, we can calculate the temperature, body temperature, in terms of degree Celsius or degree Fahrenheit. So this is a product of science, and it works on the of course heat and its properties. Okay. So and we have so many concepts we can entropy and enthalpy. So like various concepts, and specific heat, correct? So specific heat and we can say the boiling point and the melting point, all these things comes under the thermodynamics, which is highly useful for regular concepts. Am I correct? And how the cooker works, how the refrigerator works. So they will ask a simple question to you. So because you have to explain the concepts by applying your regular daily life situation. I will ask a simple question to you. So that's a hot summer, there is no AC at your house. Okay, you don't feel even the air produced by fan also not comfortable to you. You have the refrigerator in our room. Just you open the refrigerator door, or your rule of course room is going to be cool or not. I will repeat my question. It's a hot summer, the external temperature is more than 35 degrees Celsius. You enter into that your room, you want to make your room is cool, little bit of cool. So you don't have any air conditioner, simply just you open your refrigerator door. Is the room temperature will be decreases or not? I understand my question. Room temperature will not decrease, room temperature will be increased, and current or electricity consumed is more. The reason here, the temperature inside the refrigerator around 10 degrees Celsius, less than 10 degrees Celsius, and the room temperature is around 24 degrees Celsius to 35, because external is 35 degrees. Okay, generally the heat travels from high to low, high temperature to low temperature, correct? So it means it takes some heat from the room to refrigerator, so it consumes more electricity. At the same time, when this temperature downs, it gets the temperature from the external environment, so means the room temperature increases. So, if you want to make a room, your room, you can use air coolers or air conditioners, but do not open your refrigerators, because there is no possibility for reducing the temperature or not. So, this very interesting, am I correct or not? So, like you can say various concepts. For example, you stopped your fan. So, when you apply the brake, the vehicle will stop there. When you switch off that of course light, immediately it lit off. Just when you switch off the ignition in the your stove, the fire will be stopped. But when you stop a fan, of course when you switch off a fan, it takes some more time, it will not stop directly. What is the reason? It's call it as a moment of inertia. Okay. So, that means here it's still continue, but we have the capacitors on a fan. So, there is some energy is stored in it. That energy is to move for a while, for 10 seconds or 15 seconds. So, like we can pose so many questions to the children, and classroom transaction, definitely the children feels that okay, science is not new and science is not away from our daily life situation. Science is a part and parcel of our daily life situation. So, you can understand, and the children listen very interestingly, and the physical science teacher can make the classroom a highly effective manner. So, this is the most important task. I hope everyone can understand all these things. You can say other activities also, but due to time consumption, of course I won't go in depth, but all these informations are available in our resource books. So, go through it, learn the concepts and make the classroom highly effective manner, and take some teaching learning material and models, and whether it is in a visual form or in a chalk and duster form, or in charts, or in virtual lab, whatever it may be, the method of teaching, you should make the classroom highly effective. So, friends, I feel by giving all these examples, maybe everyone feels that without physics there is no life, and physics is a part and parcel of our daily life situation. So, thank you for listening. I hope you have a nice day. We will meet with another concept in the physical science methodology. Thank you for listening.